Introductions of project. To keep students engaged in the science of electromagnetism, an inspiring project is to make a simple experiment related to the concept of electromagnetic static fields and waves. The topic of our project is electromagnetic motor. This motor models electromagnetism and the functioning of an electric motor. By running a current through the magnetic wire, we create an electromagnet, which is a moving electric charge produces an electric field, and when the current carrying wire is bent in the loop, the magnetic field lines become concentrated inside the loop. The electromagnet is being attracted by the magnet under the loop because one end of the wire is completely conductive for the current, but the another end, only half the electromagnet is being turned on and off. The magnet only pulls the electromagnet when it is on, thus the electromagnet of the magnet wire loop is spinning on the armature. Although most electric motor works with reverse currents by each revolution, which switches the poles of the electromagnet, this simple electric motor spins because of the inertia of the spinning loop and the on-off functioning of small electromagnet. Now let's come to the methodology. First, starting in the center of the wire is wrapped tightly and neatly around the marker 40 times. The coin is slid off from the marker. Each loop end of the wire is wrapped around the coin a few times to hold it together. Then, point the wires away from the loop. The top half of the wire insulations is removed on each free end of the coin by using sandpaper. The exposed wire should be facing the same directions on both sides. Each loose end of the wire coin is threaded through the large eye of the needle-shaped coin. The coin is kept as straight as possible without bending the wire ends. The 1.5 AA battery is laid sideways on a flat surface. Next, some masking tape is stuck on the either sides of the battery so it does not roll away. Two small steps is used to cover the shut ends of the needle. The needles are placed upright next to the terminal of each battery so that the sides of each needle touches one end of the battery. Electrical tabs is used to secure the needles to the ends of the battery. The coil is hung above the battery, and next, a small magnet is tapped to the side of the battery so that it is centered underneath the coil. Lastly, a spin is given to the coin and the result is recorded. Now, let's move to the theory part of this experiment. The metal, needles and the wire create a closed loop circuit that can carry current. The currents flow from the negative terminal of the battery through the circuit and to the positive terminal of the battery. Current in a closed loop it also creates its own magnetic field, which can be determined by the right-hand rule. In our projects, current travels through the coin created, which is called the armature of the motor. The currents induce a magnetic field in the coin, which helps expand while the coin spins. The results that we obtain was very successful, as the coin spins without directly connected to the DC power supply. Besides that, this theory describes how magnetic energy can be converted into mechanical energy without the applications of any external energy source. The motor will continue to spin when pushed in the right direction. The motor will not spin when the initial push is in the opposite direction. As conclusion, we have successfully done the experiment regarding the electromagnetic static theory, which is the electromagnetic motor. Overall, we are satisfied with our performance in this project as we have achieved our objectives perfectly. Of course, there are some limitations, but we managed to overcome them.